In this video I'm going to work through selected parts of question 3 from the week 1 practice questions. And the first question asks us to suggest the purpose of collecting this data. So a good place to start in answering this question would be just to examine the data, and it seems like each column here represents a variable. We've got wage. It's not stated how this is actually measured, but it could be an hourly rate, perhaps it could be an annual wage, although there are some pretty low ones in here. Then this looks like years of education, probably years of experience, hours worked, that seems per week, and then we've got a series of qualitative variables here. This one, for example, seems to indicate whether a person is married or not. 1 is likely to indicate that they are married, 0 that they're not. On balance then, it seems like these variables would have the wage as the dependent variable, the thing we're trying to explain, and these other variables are being used as explanatory variables, it would seem. The next question I will skip over, B, and also C, and just refer you to some written solutions on Blackboard for that. Part D says, how many elements does the dataset contain and what does each element actually represent? So each row is an element and it seems to represent a person. The number of elements, well, we can scroll down to the bottom of this dataset and see that it finishes in row 1001. Our first element was in row 2, so there's 1,000 elements in this sample. Can you identify index numbers for the elements in this data set is part E. Well, the answer is no, there are no index numbers, but if we wanted to, we could easily add them. I'm going to call the index I. I'll just copy that format across, and I'll show you one way that we could fill out these indices. Now I'm just going to say that the first element is 1, the next element in this data set is 2, and to fill down these things I'm going to put 1 in the first cell, then I'm going to click on that cell and add 1, and if I drag that down it should give me the numbers that I'm interested in. And if I go all the way down to 1001, I will have given an index number to each element. Remember, an index number is a unique identifier for each element, and it just helps if we want to talk about a particular element, that there's a common reference point. For example, this person has the index number 9. Moving on, part F asks us to do a histogram for the data in column A. Well, that's actually now column B. It's the wages variable that we're looking at. And to produce a histogram, we're going to go into data, data analysis, choose histogram. Then our input range, I'm going to select wage and then scroll down this column to select all the observations for wage. This first question says to just let Excel automatically select the bin, so leave this blank. I've ticked labels because when I selected my input range I included that wage cell. I'm going to create this histogram in a new worksheet and I'm going to call it wage histogram 1, and I want to produce chart output, which you see I've already ticked, so tick that in your case, and away we go. These highlighted cells are a frequency table, and the way we would interpret this is that, for example, this row is telling us that for people in the range of wages but just over 1.97 and up to and including 4.370645, there are 6 observations out of our 1000. So remember, these bins are the upper end of a range of values, and this frequency is the number that are in the range from just above that one to this value. This number is all the observations that are just above that wage value up to and including that one. And we can see them graphed here in the histogram, which I'll just expand so we can see it a little easier. There it is. You can see that there's a positive skew here. There's a lot of people with wages in this kind of range, the 9 through to 16, 18. Very few people down at this very low end. But then in terms of high incomes, there's a long tail. There are quite a few people out here that are a long way away from the majority back here. And this is pretty typical of an income distribution. We could pretty up this histogram, click on these heading, title, the axes labels, and change those if we wanted to. We could right click on that frequency legend and delete it. We could also pretty up these numbers on the axis here, and perhaps remove the gaps between the bars if we wanted to. But for now, we've got the basic idea. If you wanted to do any of those things, just remember, you would right click, and that generally gives you a range of options, one of which will usually allow you to do what you're interested in doing. Down here, for example, I'd click on that. Format access probably is the way to go. I'll skip over F2, which asks something about a relative frequency histogram, but there are comments on that in the written solutions. The next question, though, asks us to produce another histogram. This time, though, we are asked to use our own bins rather than ones that Excel chooses. So that means that I need to type these bins into a column. The bins are to be 5, 10, 15, ... up to 75. I'll use the trick that I showed you before to quickly complete all these bins. So I'm going to say equals that cell plus 5, and then drag that down until I get to 75. So my bins are now set up, and I can do the same thing that we did last time to produce the histogram, which was data analysis, histogram. Our data is still the same. Now though, we need to identify the bin range. So I'll just highlight those bins that we just created. Yes, in both of these, the input range and the bin range, I included a label, a heading, so I'll leave that ticked. I'm going to produce this in a new worksheet, which I'll call wage histogram 2. And at this stage, the only extra that I want is some chart output. So let's hit OK and see what it produces. So again, we get the frequency table. Here's the histogram. And you can see, compared to the first one, there are fewer categories along here. And the histogram looks a little bit smoother, while it does tend to follow it follows the same basic shape, in that there's this positive skew. Most of the values in this kind of low range, but some observations that are quite a long way away from the majority. One other thing you might note here is that the frequencies measured on this scale are a bit higher than the ones we saw in the first histogram, and that's because in this one we just have fewer categories. We're spreading the 1,000 observations over fewer categories, so that means that there tends to be more in each of our categories. Okay, I'll skip H and I and again refer you to the written solutions. Part J asks us to estimate a few things, a few statistics in fact, based on our histograms. And the first one is the minimum value for wages. I'll just use this histogram. So that The lowest values are somewhere between 0 and 5. The lowest value, on just looking at this, I'd suggest maybe halfway, so let's say 1 or 2 is my estimate of the lowest point. The maximum, well, it seems to be a bit above 75. There seems to be one or a very small number of observations just a bit above that. So it's a fraction over 75, I think, is the maximum. The median is the middle, and that, given that we have 1,000 observations here, that means that we're looking for roughly the 500th observation with the wages in order. And on this histogram, I can see that there are about 200 in this category, a little bit over 200 in this one, a small number here. So I'm at just a fraction over 400 by the time I get up to 15, which is this value. And then I have roughly 200 in this next category, and I want to go roughly halfway through that. So this category is ranging from 15 to 20. The 500th value I'm estimating is about halfway, so something like 17 or 18. The mean for a positively skewed distribution like this, with a long tail to the right, is generally going to be a bit higher than the median, and that is because these high values that are quite a long way away from the majority, tend to drag the mean out towards that tail. So I think we said the median was somewhere around here, so I'm going to suggest the mean is going to be somewhere in this kind of range. So that's sort of like 20 to 25 perhaps. One thing we can be pretty certain about though is that this mean is going to be above the median because of this positive skew. Standard deviation, I'm going to do this in a pretty rough and ready way. You'll probably remember from previously seeing the normal distribution that about or more than 99% of all observations tend to lie within 3 standard deviations either side of the mean. And so that means that if we were to look at the range of values and calculate the range, which is the maximum minus the minimum, and divide that by 6, in a large data set, that should roughly give us an approximation for the standard deviation. Now, while this histogram is not exactly normal, I'm still going to crudely use this same kind of approximation to guess at its standard deviation. So, the maximum value is somewhere around 75. The minimum value is somewhere in the range of 0 to 5. Roughly then the range is about 70. I'm going to divide that by 6 to get an estimate for the standard deviation, and 70 divided by 6 is about 12. So in a rough and ready way, this is my estimate of the standard deviation. Skewness would be 0 if the distribution was symmetrical. If you see this kind of positive skew, so that means a longer tail to the right hand side, then such a distribution will have a skewness that is positive. So that's what I'm expecting to see for this distribution. And finally, excess kurtosis. I'm going to skip over that for now. It's a little problematic to discuss, and I can assure you though that you won't be seeing this one in the quiz coming up in week 2. The final thing we were asked to do was to generate some summary statistics for the wages data to compare our estimates to. And to do that, we are going to again go to data analysis, choose descriptive statistics this time. Rather than manually selecting things, I'm just going to select left click on the B there, that column heading, and this is another way, a shortcut way that will allow us to get descriptive statistics for that data. My column is grouped by columns, yes. In the first row I did include a label wage. I want to produce that as a new worksheet. I'm going to call it wage summary stats, yes. And I need to click summary statistics to tell Excel what it is that I actually want from it. Just bear in mind, because I've already done this exercise, all of those things automatically popped up, but for you, you would have to type in this title, and you would have had to manually click the summary statistics. Okay, we'll hit OK and see what comes up. I've just highlighted those two columns, and I'm going to double click here to resize the column width. And there are our results. The count is 1,000, which gives me confidence that the summary statistics are being calculated correctly. And I'll leave it to you to compare the actual statistics calculated here with the estimates that you came up with in Part J. And that is a quick and dirty tour of question 3.